Hi, hello everyone, very good evening one and all. Welcome to the most comprehensive preparation app for all competitive exams by Byjus Exam Prep, and warm welcome to Master MSQ series. Join the session quickly and mark your presence. I am Satya, waiting for you all with good questions, good MSQ questions from computer organization and architecture. Join the session quickly. Let me know, am I visible and audible clearly or not, everybody? Those who have joined the session, please do share the session info to your friends wherever you are connected. Let them know this session happening so that they will also join and benefit out of this session. Hello Lalit Yadav, Dheeraj, good evening. Am I visible and audible for everybody? Keep liking and keep sharing the session, dear friends. Today we are going to solve MSQ model questions of computer organization and architecture subject, and operating system subject MSQ session was actually postponed to coming Tuesday, so it will happen on Tuesday, the coming Tuesday, 31st Jan. Okay, chalo. Hi Ayush. So before I start, let me introduce myself quickly. I am Satya with 15 plus years of teaching experience, mentored more than 35,000 students in the GATE and PSU segments. I am qualified in GATE, UGC NET, SET and also certified by Cisco. Now, Byjus Exam Prep is conducting the Mega Mock Challenge. It is conducting on a regular basis for your benefit, and it's a free Mega Mock Test, all India level Mega Mock Test. By attending this kind of full length Mega Mock Test all India wide, you can know where you stand in this heavy competition, because you will be shared the all India level rank prediction with your performance. So this would be live till 30th Jan, guys. If you have not taken yet, please do register for this all India open Mega Mock Test and take the exam and get prepared by assessing your mistakes. Okay. Our favorite Rakesh Thalreja sir would be coming live on 29th Jan at 12:30 p.m. and he will be sharing 7 golden rules to secure a single digit rank in 2024 GATE exam. So this is useful for 2024 aspirants. So if you have any of your juniors or classmates or friends preparing for 2024, please do suggest this session. It would be more helpful for them. It is on 29th Jan, 12:30 p.m. Now, guys, we are coming up with this GATE Super 11, which is a very successful series, because whatever the Super 11 questions that we give every year from every subject, mostly from these model questions, definitely you will get questions in the actual GATE exam. That's why the Super 11 series became very popular and very useful series. So from today it is getting started. Today you have DV Sridhar sir class at 9 p.m. of this Super 11 series. So do attend that. Okay. And yes, so our GATE exam is just almost 1 week away. So how are you feeling, guys? Are you tensed? Are you tensed? Do you have any sort of tension, pressure? So on 4th and 5th for computer science, electrical and electronics, this of course mechanical is also happening on this 4th and 5th, and we are coming live soon after the exam is over. We will be doing the analysis of the same. Okay, and please write the exam that 3 hours is what yours. 3 hours is what yours. So that 3 hours performance decide your entire career. So guys, leave all the tension, all the pressure. Okay, just try to pack the things. Whatever you have learned, learn completely. Whatever you have learned, do rigorous exercise on the same for the perfection, speed and accuracy. That would more suffice, because instead of learning new things and getting irritated, getting demotivated, better what you learned till now, wrap up them, and on the same you do exercise. Okay, that will improve your speed and accuracy, so that whatever the things you learned, or for how many marks you are preparing, let's say for 80 marks only you are prepared, or for 85 marks only you prepared, or 70 marks only you prepared, no problem. So focus on that 70, how you can minimize the errors, how you can minimize the negative marking, how you can gain max out of this 70. That would suffice. Okay, fine. Okay, so Lalit, feeling excited to see the paper. Good. Kamal, have done all prep. Minor miscalculation is happening again and again. Yes, Kamal. So identify the reason for that miscalculation. Are you doing in hurry, or you are not using the calculator? You are just solving on your own on the pen and paper, or you are taking the wrong values by confusing. So what is actually driving you for the mistake? Try to understand that and try to overcome that. No problem. Still we have 1 week left. Okay. So better use virtual calculator. That save lot of time, Kamal, because calculator will not do silly mistakes. If you give the input correct, definitely calculator will give accurate value. So habituate, practice using virtual calculator. Okay, that would save lot of time. Chalo. Now let us start the MSQ practice of COA with the first question on your screen. Here is the first question, dear friends. Yes. Consider the addressing modes and their applications given below. Which of the following pairs are valid? Yes. What would be your answer? What would be your answer? B and D. Okay. I want answer from everybody, please. Kamal says only B. Anu, B. Okay. Ayush, you are not 100% sure. Okay. No worries. No worries, Ayush. So you are done with giving the answers? Fine. First of all, whenever we want to relocate the program, relocation means everybody know, copying from one address to another address. So there offset plays very important role, right? But if you just have offset, it would not suffice, it would not be enough. Base address is also needed, right? So for program relocation, based addressing is used. So this is definitely valid. And vector implementation. What is vector implementation? Vector means what here? Here vector means one dimensional array, 1D array. We know 1D array, another name is vector. 2D array, another name is matrix. 3D array, another name is cube. Right, we know. 4D array, quad. So we have certain technical names. So 1D array, another name is vector. So for array implementation, how do you implement the array? How do you access elements of the array? With index. So indexed addressing is used for array implementation, most suitable addressing mode. But here indexed addressing is not given. Please understand, scaled addressing is also called as indexed addressing. That index is what you call as a scale factor. With the scale factor, index can be retrieved. So scaled addressing, indexed addressing are same. So yes, option D is also true. Relative addressing is used for 1D implementation? No. Relative addressing is used for what? For program sequencing. Means in which order to execute the program. What is the next instruction to be executed? What we use? Program counter. Program counter register used in which addressing mode? Relative addressing mode. So for program sequencing, relative addressing is more suitable. Hence this is false, this is false. Yes, you are correct. The right answer is option B and option D. Auto increment, auto decrement, Ayush. Okay. Chalo. Next question. Suppose that memory location 1000, 2000 and 3000 has content 2000, 30, 40 respectively. If an instruction add R, OP1, OP2. Guys, this is complete instruction. Add R, OP1, OP2. If you want, I can write again here. R, OP1, OP2. Produce output as 70. Then identify correct representation of these OP1 and OP2. Correct statement with regard to this means what would be OP1, what should be OP2, then you will get the output as 70 in R. Yes. Lalit says A and C. All right. What about others? Ayush, as far as I know, they are called auto increment, auto decrement. Other names I am also not aware. If you know, please let us know. Ayush says A, C, D. Okay. What about others? Everybody please give your answers for this question in the chat box. Anu says B and D. All right. Okay. If OP1 is equal to 2000, OP2 equal to 3000. OP1 is 2000 means what is there at 2000? At 2000 we have 30. So R will have value of 2000 plus value at 3000. That means R will have 30 plus 40, 70. Yes. So definitely OP1 and OP2, if they are 2000, 3000, definitely the output would be 7070. Second option, OP1 equal to at the rate 1000, OP2 equal to at the rate 2000. What is the meaning of at the rate? At the rate is telling you it is a indirect address. At the rate means it's a indirect address. So it means M of 1000 plus M of 2000. Right? So what is there at 1000? 2000. What is there at 2000? 30. Plus what is there at 2000? 30. What is there at 30? We don't know, not given. So it may be 40, it may not be 40. So we are not sure of this value at address 30. Hence we can't assure that this will produce 70. Okay. Then option C, OP1 equal to hash 30, OP2 equal to hash 40. Hash indicates that is immediate operand. That means we have to consider them as values directly. So option C is telling R is equal to value 30 plus value 40. So yes, it is producing the output 70. Then option D, OP1 equal to at the rate 1000. So it is telling M of 1000 plus OP2 equal to 3000. Simply 3000 in brackets, even if they are represented in parenthesis or not, it means the address. Parenthesis is optional. So what is there at M of 1000? At 1000 I have 2000, at 2000 I have 30. So this would be 30 plus at 3000 what I have? 40. So yes, this is producing 70 as output, hence option D also. So hence the correct answer should be A, C, D. So you have to select these three, A, C and D. Okay. As the value at 30 is not given, we can't assure of it. Chalo. Next question. Choose the correct statement or statements from below such that CLV and CAV indicates the disk head rotational behavior as constant linear velocity and constant angular velocity respectively. We have options. The recording density is high in innermost cylinder for CLV. It is low in outermost cylinder for CLV. It is high in innermost cylinder for CAV. It is the same in each cylinder for CLV. So what is the correct statement? C and D. Okay. Okay. What about others? Lalit, Anu, all the others, please give your answer for this question. Anu says D, Ayush says CD. Okay. Guys, remember, constant linear velocity. This design indicates fixed density, varying capacity. Small track will have small capacity, big track will have large capacity, huge capacity. And CAV is for reverse, varying density and fixed capacity. This CLV is used in optical discs, whereas the CAV, magnetic disc, floppy disk, are based on CAV design. Okay. So the recording density is high in innermost cylinder, low in outermost cylinder. For CLV, it can't be different in cylinder, I mean in innermost track or outermost track. So track to track the density won't vary, hence these are wrong. It is high in innermost cylinder for CAV, yes. It is same in each cylinder for CLV, yes. So we want the correct statement, hence the answer should be C and D. Okay. Shall we proceed to next question? Everybody, shall we proceed to next question? Please do respond. Chal. Next question. Pick the correct pair from below with respect to cache mapping technique and tag information maintained by respective cache controller. Options: direct mapped cache, main memory block number; associative mapped cache, main memory block number; direct mapped cache, main memory page number; set associative mapped cache, main memory block number. So pick correct pair or pairs from below. Yes, please. What's your answer for this? Ayush says C and D. B not sure. Okay. Please understand, if it is a direct mapped cache, the address is interpreted as tag, block offset and word offset. This is what cache block offset, right? If it is associative mapped cache, tag and just word offset. If it is a set associative mapped cache, it interprets the CPU generated address as the tag, set offset and word offset, right? So here this field is what indicating main memory block number. So which is maintaining directly main memory block number as a tag? Associative mapped cache maintain the main memory block number. That's why it would be unique for every block. Every cache block maintain unique tag because it maintain main memory block number. Main memory block number can't be duplicated. That's why hit latency is high in associative mapping technique. And what is direct mapped cache is doing? That main memory block number, it is partitioning into tag and block offset. So tag means it is not complete main memory block number, that is main memory page number. What is page here? Page means DM cache interpret main memory as group of cache memories. That main memory's cache portion is called page. So that page number is what maintained as the tag by DM cache. And set associative mapped cache maintain main memory block number as the tag? No. It is not maintaining complete main memory block number as tag, right? In that set offset is also there. So tag is not equal to main memory block number, right? So it is false. Hence the correct pair means only B and C. Clear? Deepak, Lalit, Ayush, Anu, everybody? Am I clear? Is it so, Deepak? Not sure. Have you subscribed to our BEP YouTube channel? I think this is in the subscribers mode. Only subscribers can send their messages, I think. Maybe that could be the reason. Check once. Ayush, which is also page number? Set offset is not page number here. There is no page concept for SAM at all. No page concept for SAM, only for DM it is. Okay, chalo, next question. A CPU has only 5 byte instructions. A program starting address is 104. Find the correct legal program counter value. Find the correct legal program counter value. Okay, Ayush says A and C, Shyam A and C. Okay, okay. See, every byte instruction, every instruction size is 5 bytes. So, if you assume series of instructions I1, I2, I3, I4, I5 so on, if when I1 size is 104, when it is a 5 byte instruction, as nothing is mentioned, you can understand word addressable, one word equal to 1 byte. So 5 addresses would be on its name: 104, 105, 106, 107, 108. So these would be the addresses. We know for any content, starting address is considered as address of anything. So if I1 address is 104, I2 address is becoming 109, assuming if they are stored sequentially. Next address would be 114. Next address would be 119. That means whatever the value you get, that minus starting address when you do, that should be divisible by 5. So option A, 134 minus 104 mod 5, is it equal to 0? 30 mod 5, it is equal to 0. True. So yes, it is a legal program counter. Similarly, option B, 146 minus 104 mod 5, is it equal to 0? This is 42 mod 5, that is equal to 2. So it is false. Option C, 224 minus 104 mod 5, is it equal to 0? Why I am doing mod 5? Because instruction size is given as 5 here. So 224 minus 104 is 120, mod 5 equal to 0, yes. So it is valid program counter. And 348 minus 104 mod 5, is it equal to 0? 348, so you will get 244 mod 5 is equal to 0, false. Hence it is not a legal program counter. So only A and C are legal program counter values. Ayush, no Ayush, there is no page concept at all. It is not page number. Main memory block number bits is composition of set number and tag. Set number and tag. There is no page concept at all, because there we will mod with main number of cache blocks for DM. For SAM, we will mod with number of sets. Both are not same. So such concept is not there in SAM. And DM interpret main memory as group of cache memories or group of pages. SAM interpret SAM group its own blocks into sets. So both organizations are different. Okay, fine. Now our GATE and ESE test series is available for you to strengthen your practice. In this you will get 4000 plus practice questions, 60 plus full length tests and subject wise tests together. You have virtual calculator would be given, and detailed analysis would be provided. So do acquire this test series. For details, you can visit our app or website. Okay. Next question. Choose the incorrect statement or statements from below. CISC supports only 3 address and 2 address instruction formats. RISC supports both 0 address and 1 address instruction formats. CISC supports only memory operands. RISC supports only register and immediate operands. What would be your answer? Lalit says AC, okay. Pujara, AC. Ayush, C, okay. Guys, A is wrong, C is wrong, D also wrong. Why? RISC supports only register operands. Immediate operands means values. No, RISC follow register architecture. Register ISA. So it supports only register operands. So option D also wrong. CISC supports only memory operands. No, it supports register operands and IO operands. 2 means immediate operands too. And RISC supports 0 address, 1 address. Yes, RISC supports 0 address, 1 address instruction formats. But guys, here you please understand, RISC supports fixed length instruction format, we say. Generally, we use 3 register operands while you use RISC instructions, right? But we can use 1 address, 0 address instruction formats. What do you say? Generally, we use 3 register operands for RISC instructions. Generally, 3 register operands means, does it mean 1 address format, 0 address format? CISC supports only 3 address and 2 address. No, it supports 0 address as well as 1 address. That's why that is false. So RISC supports both 0 address and 1 address. I want clarity on this. Does RISC supports both 0 address and 1 address? Everybody say yes or no. Think and say. Do RISC supports 0 address and 1 address instruction formats? If so, why we say RISC is having fixed length instruction format? Because these are contradictory. If it supports 0 address, 1 address, you may have an instruction without operand, with operand. That means length of instruction is varying. When length of instruction varies, why we say RISC supports fixed length instruction format? Think once. Opcode may be variable. Opcode, however, will may be variable for any format. Where is the question of opcode here? Why do you take opcode may be variable? See, opcode can be anything, but its length would be fixed, dear Lalit, because if RISC is having 12 opcodes, you use any opcode in that, you use 4 bits for that opcode. So the length of opcode will be fixed, whether in CISC or RISC. But how come CISC is becoming variable length instruction? Because in some instruction you may specify 2 operands, in some other 3 operands, in some other 1 operand, in some other no operand. In that way, it is having variable length instruction format. But RISC generally we use 3 register operands, and it supports load store architecture through registers only, that all that story you know. So my question is, when RISC supports both 0 address and 1 address, how come we say RISC supports fixed length instruction format? Yes, while doing arithmetic computations, please understand, where is this? While doing arithmetic operations, RISC supports only register operands, not always. While doing these arithmetic operations, RISC supports register operands, and it supports load store architecture. So it supports values also and memory operand also. So that's why this is true. Okay. So you should select A, C and D. Chalo, next question. Identify the true statement or statements from below. Microprogrammed control unit is based on CISC instruction format. Hardwired control unit is based on RISC instruction format. Horizontally microprogrammed control unit is faster in generating control signals than vertically microprogrammed control unit. Hardwired control unit is faster than microprogrammed control unit in generating control signals. Yes, please. Identify the true statement. Deepak says A, B, C, D. Okay. Yep. All are true. Microprogrammed control unit. Yes, it is based on CISC design. Hardwired control unit is based on RISC. Correct. Horizontally microprogrammed is faster because no decoders required. No encoding, so no decoding. That's why horizontally microprogrammed control unit is faster. And hardwired control unit generate control signals directly. There is no need of decoding, no need of again this what we say direct control signal it will give to the hardware. No need of decoding or no need of fetching. No need to fetch the micro instruction from memory. So the time will be saved in hardwired, hence it is faster. So all are true. So you have to select all. CN marathon already done beta. It is there in the playlist. You can just go to our playlist once. In that playlist you can find marathon playlist. There you can see all the marathons. Okay. Next question. Consider a processor that generates 32-bit addresses using 128 kilobyte cache memory with 64-byte blocks in both direct and set associative configurations. Identify the false claims from below. A direct mapped cache controller uses 17-bit tag for each block. A direct mapped cache controller uses 15-bit tag for each byte. An 8-way SAM uses 18-bit tag for each set. An 8-way SAM uses 18-bit tag for each block. Identify the false claim. Quick. I know it takes little time, so let me solve along with you. It generates 32-bit address, 128 kilobyte cache we have, and block size 64 bytes. So 32-bit address, 128 kilobyte cache memory we are having, and block size 64 bytes. Okay. So if I take for direct mapped cache, DM interpretation would be tag, block offset and word offset. Word offset indicates block size, block offset indicates cache size, right? As one block is 64 bytes, it is of 6 bits. And cache is having 128 kilobyte with 64 byte blocks. So let us calculate number of cache blocks once. That is cache size divided by block size. So it is 2k, that means 2 raised to 11 blocks, hence block offset would be 11 bits. So out of 32, 11 plus 6, 17 bits gone, so 15 bits would be left for the tag. So DM 15 bit. And what about set associative mapped cache? It interprets the address as tag, set offset, word offset. Word offset, yes, 6 bits. Now to know set offset, we should know number of sets. Number of sets is equal to, and it is given 8-way SAM. Total blocks by blocks per set. So this is 2 power 11 by 2 cube, that is 2 power 8. So 8 bits for the set offset. Out of 32, 8 plus 6, 14 gone, so 18 bits left for the tag. So 2 points are confirmed. DM use 15-bit tag, 8-way SAM use 18-bit tag. So 15-bit tag, hence option A you can rule out. 18-bit tag for 8-way SAM. Yeah. So now tag is maintained for each what? Tag is always maintained for each block. Please remember, tag is always maintained for each block in any configuration, whether it is a DM configuration or set associative or associative. So for each block it is given each byte, hence this is wrong. And an 8-way SAM use 18-bit tag for each set. No, wrong. And an 8-way SAM use 18-bit tag for each block. Correct. So the false claims are A, B, C. Deepak, okay, it's not just length, it's not just length. For each what maintained tag, that also important, that is attached there. So we have to be little careful. Okay. Harshal Purohit, thank you. Students like you are what the motivation for us. Thank you so much. Okay, next question. Pick incorrect relation or relations from below. Options: hit latency of DM cache less than hit latency of AM cache less than hit latency of SAM. Option B: SAM hit latency less than DM hit latency less than AM hit latency. Option C: conflict misses in AM less than conflict misses in SAM less than conflict misses in DM. Option D: conflict misses in AM less than conflict misses in DM less than conflict misses in SAM. So which is correct? Which is correct? B and D. Ayush, A, C incorrect asked. Okay. Anu, B, D. Guys, hit latency is high in associative mapped cache and low in DM cache. So if I talk about hit latency, I can derive the relation as DM cache would be less than SAM less than AM. And if I talk about conflict misses, it is exactly reverse. AM 0 conflict misses, SAM few conflict misses, DM high conflict misses. So DM less than AM hit latency less than SAM hit latency, this is wrong. SAM less than DM less than AM, this is also wrong. AM conflict means less than, SAM less than, DM correct. AM less than, DM less than, SAM wrong. So incorrect relations are A, B and D. Okay. Now I would like to give 2 questions for your homework. Please give your answers in the comment section or in my Telegram group. Okay. I am giving these 2 questions for your homework. Guys, there is one session at 7 p.m. On our Byjus exam prep app now. Henceforth, please accept these 2 questions as your homework and give your answers in the comment section. I will give you the answer in the comment section after the 7 p.m. session. Okay. So a gentle reminder for everybody, on 4th and 5th we will be coming with live GATE 2023 exam analysis. So stay tuned, join us for the live analysis. Okay. This is my Telegram group link. If you have not joined yet, please do join to connect with me for doubts, PDFs and for any other guidance. Thank you so much for joining the session. See you in the next session. Tomorrow I will be coming with super 11 questions of C programming. And today at 9 p.m. DV Sridhar sir will give you super 11 questions of some other subject. So do join continuously, regularly, get benefit out of this. Okay, thank you so much dear friends. See you, and if you are free you can join the 7 p.m. session on our Byjus exam prep app. Of course, there I discuss theory for 2024 aspirants. If you want to revise the deadlocks concept, you may join. Okay, that is the theory class today. Tomorrow we will have practice of deadlocks. If you would like to revise, you are welcome. Thank you. See you guys. Take care. Bye bye.